There is a moment, somewhere in the backcountry of Yellowstone, where the world goes completely quiet and then completely loud in the span of about 4 seconds. One moment the meadow is still. The grass is bending in the wind. A river is moving through the willows at the edge of your vision. And then something shifts, some signal passes through the air that you cannot decode, but every animal in a 2-mile radius apparently can. And the elk that was standing in that meadow 60 seconds ago is suddenly running. Not trotting, not moving away calmly. Running with everything it has, full extension, hooves throwing dirt, antlers laid back against its neck to cut the air, 1,000 pounds of muscle and bone in desperation moving across that landscape at speeds that do not seem physically possible for something that large. And behind it, emerging from the tree line with a terrible efficiency, the wolves. Subscribe right now if you want to understand what actually happens when the most sophisticated predators in North America go to work. Because what we are about to get into is one of the most extraordinary documented pursuits in the history of wildlife research, and the ending is not what you expect. Let us start with the numbers because the numbers are the first thing that breaks your assumptions. 9 miles, not 900 meters, not a mile and a half of hard running. 9 miles of continuous pursuit across some of the most demanding terrain in the American West, elevation changes, river crossings, deep snow in places, open ground in others, and at the end of those 9 miles the elk was still alive. The elk got away. A pack of wolves, animals that have been refined by somewhere around 5 million years of evolutionary pressure into the most effective cursorial predators on Earth. Animals that have co-evolved with elk specifically, animals that know every trick in the book because they wrote the book, chased a single elk for 9 miles and did not catch it. And the reason why is a story that goes so much deeper than just one chase on one day in one valley. It is a story about the physics of pursuit, the biology of endurance, the psychology of predator and prey, the specific intelligence of an animal that most people have radically underestimated, and the strange, counterintuitive truth about what it actually means to be the wolf in that equation. We need to go back to the beginning, not the beginning of this particular chase, but the beginning of the relationship. Because wolves and elk are not simply predator and prey in the way a cat and a mouse are predator and prey, they are something more complicated and more ancient than that. They are co-architects of each other. They have been building each other for millions of years. The North American elk, Cervus canadensis, is a large animal, very large. A mature bull elk in peak condition can weigh between 700 and 1,000 pounds. Cows are smaller, typically 400 to 600 pounds, but still formidable by almost any measure. The elk is equipped with legs that are long relative to its body in a way that is specifically calibrated for sustained locomotion across rough terrain. It has large, spreading hooves that give it traction on soft ground and snow. It has a cardiovascular system scaled to its body in a way that allows it to maintain high output over extended periods. It has lungs that are proportionally massive. And it has in its muscles a composition of fiber types that is weighted toward the slow-twitch endurance variety more than toward the fast-twitch explosive variety, which means it is built for going long rather than going fast in short bursts. The wolf, Canis lupus, is a medium-large animal. An adult male gray wolf in the northern Rockies typically weighs between 100 and 130 pounds, with exceptional individuals pushing toward 150. Compared to the elk it hunts, the wolf is not large. It cannot overpower an elk through sheer physical dominance the way a lion might overwhelm a zebra. It does not have the explosive ambush capacity of a big cat. What it has instead is something that, when you fully appreciate it, is more impressive than any of those things. It has endurance that borders on the biologically absurd, a social coordination system of extraordinary sophistication, and a strategy for hunting large prey that is less about speed and more about time. Wolves are endurance athletes in a way that very few animals on Earth can match. They are capable of traveling 30 to 40 miles in a single day across normal terrain. In pursuit of prey, they can maintain running speeds of 25 to 30 miles per hour for extended periods. They do not tire in the way most animals tire. Their metabolism is calibrated for sustained output. Their thermoregulation is efficient. Their stride is economical. And crucially, they can hunt cooperatively, which means the effort of the chase can be distributed across multiple animals in ways that allow the pack to operate for far longer than any individual wolf could sustain. But here is the thing that people misunderstand about wolf hunting strategy. The chase is not usually the main event. It is the diagnostic. It is how the wolves read the animal they are pursuing. When a wolf pack picks up the scent of an elk herd and begins to move toward it, the initial approach is not about catching anything. It is about assessment. The wolves are watching how the herd responds. They are looking for the animal that reacts wrong, the one that does not run when the others run, the one that runs but not quite right, a slight hitch in the gait, a stiffness in the shoulder, a tendency to fall behind the group by just a little. The one whose fear response is delayed, possibly indicating illness or compromised neurological function. The wolves are reading a language written in movement, and they have been reading this language for so long that they read it the way you read words on a page, without conscious effort, instantly and accurately. The initial flush when the wolves first show themselves to the herd and the herd explodes into movement is a test. The wolves are watching to see who is compromised. In most situations, they identify a target within the first few minutes of that initial movement. The rest of the herd runs away, the pack focuses, and then the real chase begins. The chase that we are talking about today, the 9-mile pursuit that has been documented and studied, and that is one of the most remarkable recorded instances of predator-prey interaction in modern wildlife research, did not follow the normal script. The elk that the wolves targeted on that day in the greater Yellowstone ecosystem was not obviously compromised. It was not a calf or an elderly animal or a visibly injured one. It was a mature cow in what appeared, at least initially, to be good condition. And what happened over the next several hours tells us things about both wolves and elk that fundamentally change how you understand these animals. Let us talk about what 9 miles actually means in the landscape of Yellowstone's backcountry. This is not 9 miles on a flat road. It is 9 miles of terrain that shifts between open grassland and dense timber, between riverine corridors thick with willows where footing is unpredictable, and open hillsides where the wind comes off the peaks and the snow can be knee-deep in the depressions. It includes elevation changes, the kind that a human hiker would call significant, places where the grade steepens and the footing becomes uncertain, and the oxygen-depleted air at altitude adds another layer of physiological stress to an animal that is already running at maximum output. 9 miles of that terrain is not 9 miles of the kind we normally measure distances in. It is a different kind of 9 miles entirely. The chase began in what researchers described as a broad river meadow, the kind of open ground that is actually not ideal for elk when wolves are involved, because there is nowhere to use terrain to advantage. In dense forest, an elk can use obstacles to disrupt pursuit, forcing wolves to go around fallen trees or through brush that slows them while the elk's longer legs maintain pace more easily. On a hillside, an elk can use gravity strategically, moving uphill where its larger mass is actually an advantage relative to the wolves, whose smaller bodies lose more ground per stride when climbing steeply. In a river, an elk can use the water itself, because wolves are not significantly impeded by water, but elk in a river can kick backward with devastating force, and the combination of current and confined space changes the geometry of the pursuit in ways that sometimes favor the prey. In an open meadow, none of these advantages are available. It is just physics. Who can run faster and who can run longer. The initial burst off the meadow was fast. Observers estimated the elk was covering ground at close to 35 miles per hour in the first moments of the chase, the full explosive power of an animal that weighs close to 600 pounds channeled entirely into forward motion. The wolves were slower, 25 to 28 miles per hour, but they were not trying to close the gap immediately. They were running to establish what trackers and researchers call chase contact, close enough to see the animal clearly and read its movement, far enough back that they are not burning their own reserves trying to close every yard as quickly as possible. They were settling into the chase with the patience of animals that understand, at some level below conscious strategy, that time is their ally. The first mile saw the elk pull away. Not dramatically but measurably, the gap between the lead wolf and the elk opening from perhaps 200 meters to perhaps 300. The wolf pack, 4 animals in this case, 2 adults and 2 younger wolves that had come out of the previous year's litter, maintained their pace. They did not accelerate, they were not alarmed by the distance. They had seen this before, or something like their bodies had seen it in the accumulated instincts of a very long lineage. Here is something important about wolf pack structure in a chase. Not all wolves run at the same position in the pursuit. There is usually a lead animal, typically the most experienced and dominant hunter in the group, who reads the prey animal and makes the tactical decisions about when to push and when to back off. Behind the lead are the others, running in a rough formation, conserving energy relative to the leader because they are running in broken air, and because they are not doing the cognitive work of reading and tracking. This is not conscious coordination in the way human military tactics are conscious, but it functions like coordination. The wolves move as a system in a way that allows them to be more effective collectively than they could be individually. The second and third miles of the chase took the animals into timber. Lodgepole pine forest, the dense, even-aged forest that covers much of Yellowstone's interior, the legacy of the catastrophic fires of 1988 that burned more than a third of the park and created the monoculture of young lodgepoles that now dominates the landscape. In this forest, the rules changed slightly. The elk's longer stride became an advantage in the openings between trees. The wolves had to thread through the trunks with more lateral movement, each deviation costing energy. But the elk also had to navigate and at speed in terrain where a single misjudgment, a hoof catching a root, a slight wrong angle on a snow-covered slope could mean a stumble that the wolves would close in seconds. The elk did not stumble. This is worth noting because a statistically significant number of chases end in the timber when the prey animal goes down in footing that betrayed it. The elk moved through the lodgepoles with a sureness that suggested either extraordinary physical condition or the particular desperate genius that fear seems to unlock in prey animals, a heightened situational awareness, where every footfall is calculated at a speed that normal consciousness cannot explain. Sports scientists have a concept called the clutch performance, the ability of certain athletes to perform above their normal level when the stakes are highest. What the elk was doing in those timber miles was something like that, movement quality that exceeded what you would expect from any individual assessment of its capabilities, because the assessment was being done at a moment when the full resource of its nervous system was dedicated to exactly one task. The wolves came out of the timber still behind, but the gap had closed during the miles in the trees, back to perhaps 150 meters. And here the chase crossed a river. River crossings are pivotal moments in extended wolf-elk chases, and the documentation of this particular crossing is one of the most interesting parts of the recorded account. The river in question was one of the many tributaries that feed the main rivers of the Yellowstone drainage, not enormous but substantial, perhaps 30 meters wide at the crossing point, moving fast with snowmelt, running cold enough to be physiologically meaningful for animals that entered it after miles of running. The elk went in without hesitation. No pause at the bank, no apparent calculation, just the direct commitment of an animal that had understood, perhaps, that hesitation at a river crossing when wolves are 150 meters behind you is not a decision you get to revisit. The crossing was not elegant. The elk lost its footing in the current midway and went down on one shoulder, briefly submerged, came up blowing water, scrambled to the far bank and was running again within seconds of clearing the water. The wolves hit the river about 20 seconds later, and here the interesting thing happened. The lead wolf, the dominant animal, entered the river at almost exactly the spot the elk had entered. The other three wolves, instead of following directly, spread out along the bank in both directions, reading the current, looking for shallower crossings. Two of them found a narrower stretch about 60 meters upstream and crossed there, faster and with less disruption than a direct crossing would have been. One crossed directly behind the lead wolf. This is not coincidence. This is something. Whether it constitutes what we would call tactical thinking in the way humans use that phrase is a debate that researchers are genuinely still having. But functionally, what it looks like is a pack that automatically seeks to maintain formation and coverage rather than stacking up at a single crossing point and losing time. It looks like experience translated into instinct. It looks, if you're willing to use the word loosely, like intelligence. The elk came out of the river cold and wet and heavier for the water in its coat, and for a moment the wolves were not visible behind it. The river had bought it perhaps 15 seconds of not knowing where the threat was, and in a chase that would ultimately last 9 miles, 15 seconds of psychological relief is not nothing. The research on prey animal stress responses during extended pursuits suggests that these brief moments of visual or auditory separation from the predator do measurable things to the hormonal state of the prey animal, small but real reductions in the cortisol and adrenaline load that allow the cardiovascular system to fractionally recover. The elk's body was taking every advantage it could find, down to the level of seconds and hormones. Miles 4 and 5 crossed open country again, and here the character of the chase changed in a way that reveals something important about the wolf hunting strategy. The pack began to rotate. The lead wolf, which had been running hardest and doing the most work since the beginning, dropped back slightly, and one of the other adults moved up. This is a behavior that has been documented in wolf packs hunting large prey, and it is one of the things that makes them so formidable in extended pursuits. By rotating the lead position, the pack can maintain collective pressure on the prey while allowing individual animals to fractionally recover. The elk, running alone, has no such option. Every mile it covers is a mile drawn from a single account with no deposits coming in. The wolves are running from a collective account that is larger and that can be managed across multiple animals. But the elk was not reading the script it was supposed to follow. Most chases of this type end in the first 3 to 4 miles. The prey animal is either caught, which happens when it is compromised in ways the initial flush revealed, or it escapes into terrain that breaks the chase, or it reaches a point where its flight response is so depleted that it turns to face the wolves, which is a different kind of crisis but at least a different kind. At mile 5 this elk was still running. Still at a pace that the wolves could not close, still choosing its ground with the uncanny precision it had shown in the timber miles. Researchers who study elk behavior in Yellowstone have noted something that sounds almost too dramatic to be scientific, but that is nevertheless documented and discussed in the peer-reviewed literature, which is that certain individual elk seem to have what can only be described as a higher ceiling on their fear response. Most animals hit a point in a prolonged high-stress event where the physiological cost of maximum output begins to drive down performance. The muscles accumulate lactate. The oxygen debt becomes unsustainable. The animal slows and the wolves close, and what happens next is what has always happened. But certain individuals, whether through genetic endowment or conditioning or some combination of both, seem to sustain high performance under extreme duress for longer than the population average. The elk we are following was apparently one of these. Miles 6 and 7 brought the chase to a hillside. A significant hillside, the kind of slope that requires real work from any animal moving across it at speed, the grade steep enough that a human hiker would use their hands in places. And here, if the elk had any tactical awareness at all, and we will come back to whether it did, the choice to go uphill was the right one. Not dramatically, not in a way that immediately changed the outcome, but measurably the gap between the elk and the wolves began to open again on the climb. The wolf's smaller mass, which is an advantage on level ground because it means less energy expended per stride to maintain speed, becomes a liability on a steep climb where the larger animal's longer legs cover more vertical distance per stride, and the raw power of larger muscles matters more than efficiency. The elk went up the hill, all four wolves followed, and the gap opened from 150 meters to something closer to 250. What was happening inside the elk at this point in the chase is something we can describe with reasonable precision because exercise physiology is a mature science, and the basic machinery is the same across large mammals. The elk's cardiovascular system had been running at or near maximum output for something approaching 45 minutes, depending on the exact timing of the chase. Its blood lactate levels were almost certainly elevated beyond what is normally sustainable, the chemical byproduct of anaerobic metabolism building in the muscles faster than it could be cleared. Its core temperature was elevated, the thermal load of sustained extreme exertion compounded by the fact that elk, with their heavy coats optimized for cold, are not well designed to shed heat quickly when they need to. Its glycogen stores, the fast-burning carbohydrate fuel that the muscles had been relying on for the explosive phases of the chase, were being depleted. At some point, the body would shift to metabolizing fat, which is slower and provides less immediate power, and when that shift happened, the elk would slow. The wolves, running with somewhat more efficiency and distributing the load across four animals, were in better physiological shape at this point, though not by as much as you might expect. Long-distance pursuit of large prey is expensive for wolves too. Studies using GPS collaring and biologgers that monitor heart rate and temperature have shown that wolves engaged in extended pursuits operate at high fractions of their maximum metabolic output, and that recovery after a long, unsuccessful chase can take 24 hours or more. The wolves were not tireless. They were running an energy budget, and the account was not unlimited. At the top of the hill, the terrain opened into a broad alpine meadow, snow-covered, the kind of landscape that seems to erase all context and leave only the bare fact of the pursuit. Two kinds of animal, one running from and one running toward, the wind coming off the peaks, the sky enormous above everything. The elk crossed the meadow. The wolves crossed the meadow. The gap held at roughly 200 meters. And then something happened that observers described with the kind of restraint that scientists use when they are genuinely uncertain how to categorize what they have seen. The elk, which had been running in a relatively straight line since the river crossing, making small adjustments for terrain but generally proceeding in a consistent direction, changed course. Not a small adjustment. A significant change of direction, roughly 60 degrees to the left, that took it toward the far edge of the meadow where the terrain dropped away into a drainage, a steep creek valley thick with conifers. The wolves, committed to their line, took several seconds to register the change and adjust. Those seconds opened the gap by perhaps another 30 meters. Was this a decision? Did the elk look at the terrain ahead, assess the options, and make a choice to head toward cover that would give it an advantage? The honest answer is that we do not know, and the debate about the cognitive complexity of large ungulate prey responses is ongoing and unresolved. What we do know is that the direction change was consistent with optimal terrain selection for prey avoidance, that it was timed at a moment when the wolves were perhaps fractionally less attentive, because they had just crested the hill and were adjusting their own formation, and that it produced a measurable outcome in favor of the elk. Whether that outcome was the product of calculation or instinct or some combination of the two that our vocabulary does not quite have a word for, it happened. The drainage the elk entered was dense. Really dense, the kind of conifer forest that reduces visibility to a few meters in every direction, where branches come down to the ground and the snow is deep and uneven because it has been falling through canopy and accumulating in irregular patterns. Hard going, hard for wolves and hard for elk both, but hard in different ways. The wolves' advantage in agility and lateral quickness, the ability to cut and weave that makes them effective in many terrain types, was limited here because there was not room to cut and weave. You went where the forest let you go. The elk's longer legs, which had been an advantage on the uphill, were useful here too, letting it step over obstacles that the wolves had to go around. Mile 8, the pack was no longer in tight formation. The two younger wolves had fallen slightly behind, not dramatically, but enough that the effective pursuing force was now 2 animals rather than 4. One of the young wolves had apparently gone through deep snow in a depression and lost time extricating itself. The other had taken a different line through the timber and was running parallel but not catching up. The 2 adult wolves were still on the elk, still in visual contact, still reading the animal ahead of them. But the collective pressure of 4 wolves had dropped to the functional pressure of 2, and that mattered. This is another thing about wolf pack hunting that is worth understanding. The mathematics of a predator-prey interaction are not linear. 4 wolves pursuing 1 elk is not simply 4 times as effective as 1 wolf pursuing 1 elk. The relationships are more complex because coordination multiplies effectiveness in ways that straight numbers cannot capture, because different wolves play different roles in a chase, and because the presence of multiple angles of pressure means the prey animal cannot commit fully to a single escape direction. But by the same token, when the coordination breaks down, when the pack fragments because terrain has separated them, the remaining animals are not simply operating at a proportionally lower effectiveness. They are operating in a qualitatively different mode, one that is less likely to succeed against a prey animal that has shown the resilience this elk had shown. The 2 adult wolves pushed through the drainage. The elk pushed ahead of them. The drainage eventually opened back onto a slope, less steep than the one they had climbed, more gradual, and here the elk angled uphill again, not dramatically, not charging up a cliff face, but using the terrain the way a runner uses the track, choosing the line that would cost it the least while costing the wolves the most. The gap was now something close to 300 meters, far enough that visual tracking required effort. Far enough that the elk was effectively making choices the wolves could not immediately counter. 9 miles from where the chase began, in terrain that was familiar to neither the wolves nor the elk in the specific sense of this particular route over this particular ground, because the chase had covered country that neither species walks in a straight line under normal circumstances, the elk stopped running. Not because it was caught, not because it collapsed, it stopped running because the wolves had stopped chasing. The lead adult wolf, the one who had been reading this animal since the first moments in the meadow, had sat down. Just sat in the snow at the edge of a timber stand watching the elk's back as it moved away uphill. The second adult was standing 20 meters behind, breathing. The young wolves came out of the drainage a minute later and stopped near the adults, and the pack stayed there watching the elk until it disappeared over the ridge, and then they did not follow. Why? This is the question that researchers have spent considerable time on, and the answer is not simple, but it is important. The wolves did not give up because they were defeated. They gave up because they were calculating at whatever level of cognitive or physiological processing constitutes calculation for a wolf, that continuing was not worth the cost. The elk had demonstrated over 9 miles that it was not going to slow down enough to be caught. The energy expenditure required to continue was substantial, and wolves are not obligated to catch every prey animal they chase. They are obligated to survive and reproduce, and those goals are better served by a strategic withdrawal than by running to exhaustion after an animal that has repeatedly shown it will not be taken. This is one of the most important and most counterintuitive things about predation at the level of sophistication that wolves operate at. The decision not to pursue is as important as the decision to pursue. Wolves that chase every animal to the point of their own exhaustion do not leave offspring. Wolves that read the situation accurately, that can distinguish the animal that will eventually slow from the animal that will keep going for 9 miles, those wolves are more likely to eat and survive and produce the next generation. The abandonment of this chase was not a failure. It was information. Information about this particular elk, and about the general principle that the line between prey that will be caught and prey that will not be caught is drawn somewhere that is not always visible from the outside. Now let us talk about what the elk did next, because this is where the story gets strange again. Observers who maintained contact with the elk through the day documented that in the hours following the chase, the animal did something that, depending on your willingness to project, is either straightforwardly behavioral or genuinely remarkable. It found water. It found a river crossing. It drank for what was described as an extended period. It then moved into a stand of timber and stood still for something like 2 hours, not moving significantly, not feeding, just standing in the shelter of the trees. And then, when the light began to change toward evening, It moved back in the direction of the meadow where the chase had begun, picking up a path along the river that would return it to the area where it had last been with other elk. What it was doing in physiological terms is clear enough. It was rehydrating. It was allowing its cardiovascular system and its muscles to begin the recovery process. The standing in the timber was almost certainly thermoregulatory, getting out of the wind and allowing its core temperature to drop from the elevated levels of sustained extreme exertion toward something more normal. And returning toward its herd makes straightforward ecological sense, because elk are social animals and there is safety in numbers, and the specific safety of a familiar valley with familiar sight lines and familiar escape routes is meaningful. But the directness and apparent purposefulness of the recovery sequence, the way each behavior followed the previous one in an order that a sports physiologist prescribing recovery for an elite human athlete would recognize, is hard to fully attribute to pure instinct without acknowledging that at some level the elk was doing something like managing its situation. It had run 9 miles. It had survived. And now it was doing the things that needed to be done to come out of that survival in a condition to survive the next time. The wolves, for their part, were doing their own version of recovery somewhere in the terrain behind. Their tracking data over the following 24 hours showed relatively limited movement, characteristic of the post-chase recovery period that has been documented in multiple studies. They would hunt again. They would need to because the energy debt of the 9-mile chase was real and it needed to be repaid, but not today. Let us step back from this single chase and think about what it tells us about the broader system, because in Yellowstone this relationship between wolves and elk is not just an interesting wildlife story. It is one of the most extensively studied ecological relationships in the world, and the implications of that study have changed how ecologists think about entire landscapes. When wolves were reintroduced to Yellowstone in 1995, after an absence of approximately 70 years, the immediate ecological story was the obvious one. Wolves eat elk. Wolf population grows, elk population pressure changes, the herds are managed by predation in a way they had not been for 7 decades. That is the straightforward part. What came after was something that ecologists were not fully prepared for, even though in retrospect the theory was there to predict it. The phrase that became associated with the Yellowstone wolf reintroduction story is the ecology of fear. Not just the direct effect of wolves killing elk, but the indirect effect of wolves changing how elk use the landscape. Because when wolves are present, elk do not behave the same way they behave when wolves are absent. Specifically, elk avoid lingering in terrain that makes them vulnerable. The valley bottoms and riverbanks and open meadows where the sight lines are long and the escape routes are limited, and a wolf pack can close the distance before the elk can reach cover. When wolves are in the system, elk move more. They do not stay in any one place long enough to eat it down to nothing. They avoid the most exposed and dangerous landscapes and use them only briefly, on their way somewhere else. And what happens to the vegetation in those avoided landscapes is one of the more remarkable ecological stories of the past 3 decades. The willows came back. Along the rivers and streams where elk had been standing and grazing for 70 years, eating every new shoot before it could establish, the willows and aspens and cottonwoods began to grow. Not everywhere and not equally, and the relationship between wolf presence and vegetation recovery is more complex and more contested in the scientific literature than the simplest version of the story suggests. But in certain river corridors, the recovery of riparian vegetation that followed wolf reintroduction was real and measurable, and it cascaded outward in ways that few people anticipated. Beavers came back to Yellowstone rivers in greater numbers. Beavers need willows for food and dam construction, and for decades the elk had been keeping willow growth so suppressed that beavers could not sustain significant populations in the park's interior. As willows recovered, beavers returned, and beavers are what ecologists call ecosystem engineers, animals that fundamentally restructure the physical environment around them. Beaver dams create ponds. Ponds slow water flow and raise water tables. Raised water tables mean more moisture available to vegetation. More moisture supports more and different plant species. More plant diversity supports more insect diversity. More insects support more birds. The wolves changed the behavior of the elk. The behavior change of the elk changed the vegetation. The vegetation change brought back the beavers. The beavers changed the hydrology. The hydrology changed the plant communities. And so on, cascading outward through the system in a way that started with 4 wolves from Canada being released into a mountain valley in January of 1995. This is what ecologists mean when they talk about trophic cascades, and it is one of the most powerful concepts in ecology. The effects of a predator in an ecosystem do not stop at the predator's direct prey. They travel up and down and sideways through the food web in ways that are often invisible until something changes, until the predator is removed and the cascade runs in reverse, or until the predator is returned and the cascade begins again. The 9-mile chase we have been following is a single thread in this web, but it is connected to everything. Let us talk about the elk side of this more carefully, because elk are not passive actors in this story. They are not simply running around reacting to whatever the wolves do. They have their own behavioral sophistication, their own social intelligence, their own accumulated knowledge of landscape and threat that has been building in parallel with the wolves' hunting sophistication for the same millions of years. They are, in a very real sense, as good at being prey as wolves are at being predators. Elk are highly social animals, and their social structure is not simply about reproduction or resource competition, though it involves both. It is also an information network. Elk in a herd are constantly monitoring each other's behavior, reading the alarm signals that pass through a group of these animals like a wave, the head coming up, the ears rotating forward, the posture shifting from relaxed to alert, before anyone in the herd has consciously processed what they are reacting to. A single elk detecting something at the edge of its sensory range can change the behavioral state of every animal within several hundred meters within seconds, through a cascade of observational learning that requires no vocalization and no direct interaction. The herd is, in a functional sense, a distributed sensing system. The specific vocalizations of elk, particularly the alarm bark, a sharp, loud, explosive sound that carries for considerable distances, are not simply reflexive outputs of a frightened animal. They are signals directed at other elk, informative about the nature and direction of threat in ways that other elk have learned to decode. Barking elk tells the herd not just that there is something threatening, but something about the location and possibly the nature of the threat, through the direction the barking animal is facing, the pitch and urgency of the bark, the specific pattern of movement that accompanies it. The social communication system of an elk herd is a technology, evolved over millions of years, for pooling sensory information and distributing it efficiently, and it is directly competitive with the wolves' social hunting system. It is, if you want to think about it this way, the defensive version of the same evolutionary arms race. Individual elk also have long memories